Hey everybody. So we are looking at this problem, course schedule. There are a total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites I is equals to AIBI, it's a pair, indicating that you must take course BI first if you want to take course AI. So if I have an example 0, 1, indicating that to take course 0, you have to first take course 1. So this is a prerequisite. 1 is a prerequisite of 0. First complete 1 and then complete 0. Return true if you can finish all the courses, otherwise return false. Let's take this example. Num courses equals to 2, prerequisites equals to 1 comma 0. To complete the course 1, we have to first complete 0. So can we complete both the courses? Yes, we can complete 0 first and then we can complete 1. So num courses 2, we can complete both the courses. Let's take this example. Num courses is 2 over here. We need to complete 2 courses. The prerequisites is this. To complete 1, we need 0. To complete 0, we need 1. There is a interdependence, so we cannot complete anything. To complete 1, you need a 0 course, and to complete 0, you need 1 course. So for this, we are going to return an output of false. To solve this problem, we can make certain observations. Let's say num courses is equals to 5. I have courses 0, 1, 2, 3, and 4. Let's say this is the relationship between these courses. 0, and then you have 1, and then you have 2, and then you have 3 like this, and then you have a 4 like this. What this means is, to complete the course 4, you have to first complete 2 and 3 because they are pointing to 4. To complete 3, you have to first complete 1. To complete 2, you have to first complete 0. To complete 1, you have to first complete 0. So can we complete all the courses? So what if we complete 0 first? Now we can complete both 1 and 2. Once we have completed 1 and 2, we can complete 3, but not 4. We can complete 3. And we can complete 4 after that because 3 and 2 both are completed. So we can complete 4. So we completed all the courses in this order 0, 1, 2, or 2, 1. It does not really matter. And 3, and then 4. And this order has a very special name called topological order. Let's try to understand topological sort. Topological sort is basically the order in which all these tasks can be completed. So we saw one of the example as 0, 1, 2, 3, and 4 is one of the order. We can also have 0, 2, 1, 3, 4 as another order. They both are valid. So let's try to implement this. To implement this, we are going to use the in degree method. In this method, we assign an in degree value to every node, which means the number of edges coming to that node. So if we look at 4, there are 2 edges coming to 4. The in degree would be 2. For 3, there is just one edge coming, and we would not consider the outgoing edge at all. So the in degree would be 1. Over here, the in degree would be 1 again. Over here, in degree would be 1. And for 0, the in degree would be 0. There are only edges going out, not coming in. So once the in degrees are assigned, in the next step, we are going to remove all the nodes which have an in degree of 0, which means this 0 which has an in degree of 0, we can remove it. When we remove it, we can put it as part of our response that okay, 0 is the first in the order. When we remove the node, the in degree of 1 and 2, which are the adjacent of 0, would also change because now this node is gone. So we have something like this. So over here, the in degree should change from 1 to 0, and over here it should change from 1 to 0. Now we can remove all the nodes with in degree of 0. So these nodes can be removed. 1 and 2 is in the output. Graph would look something like this, and the in degree would change this time. It would become 0, and over here it would become an in degree of 1. Now we can remove the node with in degree of 0. So 3 goes to the output, it's removed from here. The graph looks something like this. The in degree over here becomes 0. Now we can remove 4, and we have 4 over here. So you can see we got one of the order. This is how you implement the topological sort, and that is what the problem is asking us for. Now that we understand the basic algorithm, let's try to look at the code implementation. I am here in the code editor. I have this function canFinish. It has two inputs, num courses, the number of courses I need to finish, and prerequisites. It's a list of all the dependencies. So let me just first of all change these names. I don't like big names because they are much harder to type. And we are returning from this function either we can complete the courses or not. First of all, I need a place to store all the in degrees. I can use a map or I can use an array. In this question, we are given that the nodes are labeled from 0 to num courses minus 1. This is these can act as indexes. So that is very convenient for us. So we are going to use that in an array. So I can say in degree, it's an array I want to create, assign it to 0, and its size is n. Since we are creating a graph, I would like to use an adjacency list. So adj, we can create it like this in Python. So we have an empty adjacency list. Next up, I would like to fill this up. Let's fill up in degree and adjacency list. For that, I would like to iterate through the prerequisite. So for I comma j in prerequisite, now the relationship given to us for 0 and 1 for these elements for these pair is that to complete 0, we have to first complete 1, which means the dependency would be like first complete 1 and then complete 0. So in a graph, we can write it like 1 points to 0. So the second element points to the first element. So the in degree of first element increases. The pointer is coming to the first element. So in degree of I is incremented by 1. And in the adjacency list, we can increment j. So this dot append I. So j pointing to I. So now our in degree is filled. Let's now iterate through this graph. If you remember the explanation, we would remove all the nodes with an in degree of 0. So let's do that. And to do that, I'm going to use a queue to store all the nodes with an in degree of 0 just for the storage purpose. So let's iterate through this in degree and find out which nodes have an in degree of 0. So for I in range n, if in degree of I is 0, this is my candidate, q dot append, and I can append I over here. Also, I would not like to use an array. I can use a dequeue in Python. Next, we are done with this. We have in the queue all the nodes with an integrity of 0. So let's iterate through this queue. While queue, let's take out the node. So node equals to queue dot top left. We have the first element with us. Now what we want to do is we want to remove this, and before we remove this we need to reduce the int degrees of the next element. So it's something like this. Let's take this example. So if I want to remove 1, I need to reduce the int degrees of these from 1 to 0, from 1 to 0. This is what we would be doing after this. For neighbor in adjacency of node, I should reduce the int degree. Int degree of this neighbor minus equals to 1. We are reducing it by 1. If the int degree of this neighbor becomes 0, let's add it in the queue and let's process it. Queue dot append the neighbor. This will make sure we are adding all these elements to the queue and they are being processed. At the end, there is a possibility that all the int degrees are 0, or there is a possibility it's negative or positive. In that case, we want to return a false. So let's iterate through the int degree again. For I in range n, if int degree at I equals to or not equals to 0, I want to return a false. We don't have an answer. If they are all 0, then return true instead. So this should be the code. Let's try to run it. Let's submit it. Okay, so we have a solution. If this video was helpful to you, please consider subscribing for more such content.